Hello everyone, myself Vibhu. Today I'm going to discuss about science related MCQ questions which are basically prepared for CBSE 10th, ICSE as well as state syllabus students. Okay, this time you people are going to write MCQ semester wise exams, right? So this class is basically the questions which I'm going to discuss about light chapter, where reflection, refraction, lens and mirror related questions I have taken here. Okay, so all right, we'll move to the first question. Which of the following can make a parallel beam of light when light from a point source is incident on it? Option A, concave mirror as well as convex lens. Option B, convex mirror as well as concave lens. Option C, two plane mirror placed at 90° to each other. Okay. Option D, concave mirror as well as concave lens. So let's see the first one. Okay, this is the concave mirror, principal axis. Okay, this is the focus. Whenever the light ray while passing via focus, I mean incident light ray, after reflection, it will go parallel to the principal axis. And this is the focus. Clear? So we have to remember whenever the incident light ray passing via focus, after hitting the reflecting surface, it will bounce back and the reflected light ray will go parallel to the principal axis. Okay, so the answer is concave mirror we can take here. Next one. Okay, convex lens. See here, this is the principal axis. This is the focus. Now what is happening? The incident light ray is going via focus. After refraction, it will go parallel to the principal axis. Here, this is the incident light ray, which is basically passing via focus. After refraction, it will go parallel to the principal axis. So we can say convex lens also will produce the parallel ray after refraction, right? So the right answer for this question is option A. Remember, whenever the light ray passing via focus after refraction or reflection, it will go parallel to the principal axis. So right answer for this question is option A. Second one, light travel fastest in. So what is light? Okay, light is a form of energy which gives the sensation of vision. Because of the light, we can see the things, right? There are two type of light is there. Okay, one is monochromatic light. Another one is composite light. Monochromatic means light is basically made up of single color or single wavelength. Okay, and composite light means light which is basically made up of multiple colors. Now come to the options, and we should remember light is the only thing in this nature which can travel faster than anything. The speed of the light can be taken as 3 into 10 to the power 8 meter per second. This is the speed of light in the air media or vacuum. But here they have given the option A water, option B air, option C glass, option D diamond. So light will travel fastest in air medium. So the right answer for this question is option B. How about the water? In water, light will travel with the speed of 2.2 into 10 to the power 8 meter per seconds. Okay. And in the glass, generally in the glass media, it will go with the speed of 2 into 10 to the power 8 meter per second. And come to the diamond, that is almost 1.5 into 10 to the power 8 meter per second, because diamond is more denser. Okay, so because of the density, there will be a disturbance for the propagation of the light, movement of the light. So obviously the speed will reduces. So but right answer for this question is A, option B. Third one, the mirror having reflecting surface curved inwards. So in generally, so I can write it here. This is the concave mirror. and the back side is coated with aluminum or silvery coated, okay, which basically the stop the light to pass this side, right? So what will happen, this is the principal axis. Whenever the light comes and falls on the surface, it will bounce back like this. This is the reflected light ray, okay, incident light ray. So this is called center of curvature of the concave mirror. This is the concave mirror, and this point is called as pole. Pole is the center part of the mirror, and this is the focus. All right. So, but the reflecting surface is curved inwards, is a concave mirror. So the right answer for this question is option D. How about the convex mirror? See here, the convex mirror can be taken as like this, where inside is coated with the silvery color, okay, and this is the center of curvature. This is the principal axis. Whenever the light will hit here, it will go like this. This is the reflected light ray. So here it is curved outwards and it is curved inwards. So this is the convex mirror, and plane mirror we will basically use in our houses for all the purpose, like dressing purpose, or in the bathroom we will use the mirror. The shaving mirror we will use as a concave mirror. All right. And cylindrical mirror, I have attached the image here. It is used as an artifacts or show items or the gift items they will use. Okay, so but right answer for this question is concave mirror, in which the reflecting surface will be curved inwards or curved towards the center of curvature. So the right answer for this question is option D. Fourth one, the mirror used as rear view mirror in vehicles. The rear view mirrors are used in the vehicle, which will helps for the driver to see the backside traffic, and which leads him to the safe drive, right? So whenever he is driving on the road, so what will happen, he should observe his left, right, as well as his backside. Is there any vehicle is there, or any person is there, any obstacle is there, you have to keep on seeing it, right? So for that, every vehicle is fitted with rear view mirrors. What kind of mirror they will use? Okay, they will use convex mirror. Okay, convex mirror will give you the wider range of view for the person, I mean the driver, so he can easily clearly see the backside things, backside vehicle, backside traffic, right? So here I have attached the image. So you people are familiar with this kind of mirror. These kind of mirror are called as rear view mirrors. Okay, and come to the plane mirror. Plane mirror in our houses we are using for dressing purpose, or in the bathroom, or for in the shaving mirror while brushing. All the purpose we'll use the plane mirror, right? Next one, cylindrical mirror, as I told in the earlier cases also, it is used in the showcase items, artifacts. Okay, they will use this kind of mirrors. And come to the concave mirror. Okay, concave mirror used majorly by dentist to see the inner part of the mouth, to see the teeth. He will use it, I mean dentist will use it. And concave mirrors are used in the headlights of the vehicle, searchlight. It is used in the shaving mirror. They will use concave mirrors. All right. So the right answer for this question is option A, convex mirror. Fifth one, the deviation of light ray from its path when it travels from one transparent medium to another transparent medium is called. So let me say that, see here, this is the one transparent medium. Just imagine that it is a glass surface. Okay, now what will happen? This is the incident, this is the normal, okay, which is basically used to study the incident light ray, refracted light ray. This is, I'll call it as a point O. This is n dash. Now what will happen? This is the incident light ray. I'll call it as the angle of incidence. After refraction, what will happen? It will changes its path. Okay, I'll call it as the angle of refraction R. By chance, if there is no xy, light would have gone like this. Is it right? It would have gone in the straight line because light will always travels in the straight line. So now what is happening? So now we'll come back here. So this is the surface XY. Okay, this is the normal. This is the incident light ray. I'll call it as the angle of incidence. And what will happen? This is the refracted light ray. I'll call it as angle of refraction. If there is no XY, light would have gone straight path, right? If you use the scale properly, you can get the proper diagram. So here I'm drawing the diagram without the scale. So, and we have to observe one thing, light will always travels in a straight line. Because of this surface XY, light is slightly bended towards this normal, right? N dash is the normal. So that is what here we are saying. The deviation is happening because of the surface XY. The process of change in the path of the light while traveling from one medium to another medium is called refraction. This is the process of refraction. So the right answer for this question is option B. Okay, how about reflection? Reflection is the process of bouncing back of the light to the same medium. So for example, in front of me, just imagine there is a mirror is there. Okay, I will take a torch light and I'll make the light to fall on it. What will happen? Light will bounce back, right? The process of bouncing back of the light to the same medium is called reflection. And how about dispersion? Okay, whenever the light is passing via optical medium like prism or rain droplet, it is going to split up into its constituent colors. Okay, white light is basically made up of 7 colors. Whenever the white light passes through the prism or an optical media like a raindrop, it is going to split up into its 7 constituent colors. This process is called dispersion. And how about the option D, scattering? Whenever the light passes through the atmosphere, because of the atmospheric particles like water droplets, dust particles, and many other constituent molecules will cause the light to split. The process of splitting of the light because of these atmospheric constituents, we will call it as a scattering of light. Okay, so but right answer for this question is option B, refraction. Okay, because of some issues it is written here. Okay, all right. Sixth question, the image which is formed behind the mirror is, okay, that is called as virtual image. Okay, and the image which is formed on the screen, we will call it as a real image. So the right answer for this question is option B. Seventh one, the phenomenon due to which a beam of light traveling through a certain medium on striking some smooth polished surface bounces off from it in this some other direction is called dash of light. This is called reflection. As I told in the earlier case, the bouncing back of the light to the same medium is called reflection. Okay, and how about polarization? Polarization is the process of making the light ray or restrict the light ray to travel in particular direction. Basically, light is when the light comes from a source, it will be scattered or splitted in the different directions, right? But in polarization, we are going to make the light rays or restrict the light rays to travel in a one particular direction. Okay, that process or phenomenon is called polarization. But right answer for this question is option C, reflection. Next, question number 8. Convex lens is also known as. Okay, let me write the diagram here. Okay, this is the convex lens. Okay, principal axis. And now incident light ray coming parallel to the principal axis. After refraction, it will passes here. Okay, let me call it as a focus. We can try one more light ray which is passing via principal axis. Even whenever the light ray passes via principal axis, it will go undeviated. Next, we'll take one more light ray which is coming parallel to the principal axis. After refraction, it is going via focus. So what is happening after refraction? All the light rays are gathering here. Is it right? Meeting at one point. That is the only case when the light rays should come parallel to the principal axis. Then after refraction, they will converge or they will meet or they will gather at one point. That's why we will call it as a convex lens, as a converging lens. Clear? So the right answer for this question is option A, converging lens. How about the diverging lens? What is the meaning of diverging lens? So let me take the, okay, this is the concave lens, principal axis. Whenever the incident light ray coming like this, after refraction, light ray will go like this here. But the person who is standing this side, it looks like all are originated from this side. So if you want, we'll take one more, it will go like this. But the person who is standing here, it looks like all are originated from the focus, but they all are coming from the some other source, from infinity, right? So in this case, it looks like all the light rays are getting splitted or deviated. So that's why concave lens is called as a diverging lens. Okay, but right answer for this question is option A, converging lens. Ninth question, which of the following medium is optically more denser? What is the meaning of denser? Where the media is thicker, where there is a disturbance for the propagation or the travel of the light. So diamond is the material which is more denser than any other optical medium. So I can say that the right answer for this question is diamond. So we already know that the speed of light is 1.25 into 10 to the power 8 meter per seconds is the right answer for this question. I mean the speed of the light. So we have to remember in the diamond. Okay. All right. So right answer for this question is option D. 10th one, the magnifying power of a concave lens is option A, always greater than 1. I mean to say that it is +1. Option B says that -1. Option C, always equal to 1. And option D can have any value. No, it is not possible. Okay. And right answer for this question is always less than 1, or it will be in the less than, I mean in the -1, -2, in that range it will be there. Okay. In the minus range it will be there. Okay, so basically for concave, it will be in the range of minus, and for the convex, it is like plus, in the range of plus. All right. So the right answer for this question is option B. 11th one, which of the following is not an example of refraction? Option A, bending of a stick when partially immersed in water. So we can see the image here when the pencil is immersed in the water. So it looks like, see, slightly, the partially, you can see here, there is a slight bending of the pencil, right? That is because of the refraction. Second one, an object placed under water appears to be raised. You take a bucket of water, drop 5 rupees coin, and when you see obliquely via normal, it looks like slightly raised up, right? But actually coin is in the bottom of the bucket only. But when you see in the proper light condition area, so it looks like slightly raised up. That is because of the refraction of light. And option C, image in a mirror. Option D, pool of water appearing to be less deep than it actually is. That is because of the refraction of light. So this image in a mirror is not because of the refraction of light. That is because of the reflection of light. So the right answer for this question is option C. Linear magnification of a mirror has no unit. What is linear magnification? Magnification can be taken as m equals hi divided by h naught. What is hi? Height of the image and height of the object. So magnification can be defined as the ratio of the height of the image to the height of the object, right? See, both height of the image and height of the object will be measured with the unit of centimeters, or you can take in the meters. It's left to you. Okay, so both numerator and denominator are having the same unit. What will happen? They will get cancel each other, either meter or centimeter centimeter. So what will happen? Both will get cancel each other. So it doesn't have any units. So magnification is a physical quantity which does not have any physical units. So it is a unitless quantity. So the right answer is yes, it has no unit. True. Option A. The radius of curvature of a concave mirror is -30. So R equals -30 centimeter. Its focal length is F equals question mark. So we already know that. What is the formula for focal length? Focal length is the half of the radius of curvature, correct? This is the formula to find out the focal length. So what is radius of curvature? That is -30 centimeter divided by 2. So 2 ones are 2 15s are. Is it right? So answer is -15 centimeter. So the focal length is -15 centimeter. The option is D. D is the right answer. So -15 centimeter. And convex mirror always produces dash and dash image. It will always produces virtual and diminished image. So the right answer for this question is option D. Okay. Real and magnified will be produced by concave. 15th one, which of the following represents the unit of linear magnification? Just now we have discussed that linear magnification doesn't have any unit. So the answer for this question is no unit. Option D. How about meter? Meter is the SI unit of length, right? So length is basically measured in meters. Diopter is the unit of power of the lens. Okay, remember power of the lens. Okay, in current electricity also we will study power, that is different, but here power of the lens is taken as diopter, or we can represent it with capital D also. And option C says that decimeter. Again, decimeter is the unit of length only. So but the right answer for this question is option D. 16th one, the focal length of a concave mirror is option A negative, option B positive, option C depends on the position of the object, option D depends on the position of image. So let me say concave mirror, principal axis, this is the pole of the mirror, pole is the center part of the mirror. Let me say that center of curvature, and let me say that focal length. I mean, this is the focus. So from here to here, I can say that this is the focal length. Focal length is the distance between the pole of and focus of the mirror. Or I can say that focal length is the half of the radius of curvature. If I say that from here to here is 4 centimeter, then the focal length will be 2 centimeter. Example. Okay. So remember, in your mirror, if you want to measure anything in the left side, okay, I mean always light will comes from the left side of the mirror, right? So remember, all the measurement must be started from the pole of the mirror. While measuring anything opposite to the direction of the light will be taken as negative. So now focal length is in this side. So that is basically while measuring from the pole of the mirror and which is opposite to the light direction, then it must be taken as negative. So remember, any measurement which is measuring opposite to the direction of the light will be taken as negative. So remember, the focal length of the concave mirror is taken as negative. Okay. So the right answer for this question is option A, negative. Okay. Option B is positive. So if you say this is the convex and this is the center of curvature, this is the focus, and from here to here is focal length. So here we can take it as a positive because we are measuring in the direction of light. So obviously light will be moving in this direction, right? From always left to right, light will travel. So if you are measuring along the direction of light, we have to take it as positive. But option C and D, it does not depends on either object or image direction where it is placed. So right answer for this question is option A, negative. 17th one, if the power of the lens is minus d. Okay, minus 2d. D stands for diopter. Diopter is the unit of power of the lens. I already told you. So what is the focal length? Question mark. See, power formula equals 1 divided by f. But they are asking you to find out the focal length. So 1 divided by p. So here what I can write, here 1 divided by minus 2, right? So what I will do here, in the denominator 2 is there, here numerator 1 is there. So what I will do, I'll put 0. So what will happen in the answer, I'll put 1 decimal point here. So because I have taken 1 0 here, so 2 1s are 2 5s are, so that is 0.5. But here in the denominator minus is there, so answer must be taken as minus only 0.5 meter. But we can see the options is in the centimeter, right? So now what will happen, the answer, the focal length, we got it as 0.5 meter. So what we have to do, we have to divide it by 100. So when you are dividing by 100, what will happen, you put dot here, so it will shift here, you put dot here, so what will happen, you have to put 1 dot here, so minus 50 centimeter. So the right answer for this question is option C, minus 50 centimeter. 18th one, the lens which is thicker at the center and thinner at the periphery is called a dash lens. Yeah. See, you can see the convex lens, okay, which is thinner at the edges and thicker at the bulge, right? In the middle part, it is bulged out. So this is called principal axis. Okay, so this is the optical center. Optical center is the center part of the lens, either it is convex lens or concave lens. So the right answer for this question is option A, convex lens. How about concave lens? Concave lens will be exactly opposite of the convex lens. So it is thicker at the edges and thinner at the middle. That is called as concave lens. Okay, next one, plano concave means one side is plane and one side is concave. That is called as plano concave lens. Okay, the right answer for this question is option D. Option A, convex lens. Okay. 19th one, according to the laws of reflection, angle of incidence is not equal to angle of reflection. Okay, where all the symbols have their standard meanings. Okay, let us take a mirror surface. Okay, just imagine it is a mirror. And how about this? This is the normal. Normal is basically taken as a perpendicular imaginary line on the surface, which basically help us to understand the angle of incidence and angle of reflection. Now what will happen? This is the normal. This is the incident light ray. Okay, so I'll call it as the angle of incidence I. So it is coming from some source. Okay, some source is kept here. Okay, any source. So this is the incident light ray and this is the reflected light ray. So R stands for angle of incidence. This is the point of incidence. So let me say that light ray will hit the surface with 30°. Obviously, it will reflect with 30° only. So let me say that it will hit the surface with 27°. It will reflect with 27°. So remember the first law of reflection. It says that angle of incidence will be equal to angle of reflection. Okay, this is the first law of reflection. So but they are saying it is not equal, right? So it is false. So option is B. But remember, angle of incidence will be always equal to angle of reflection. 20th one, the amount of light reflected depends upon. So whatever the light falls on the mirror or any smooth surface, it depends on the what kind of material it is. Nature of the material as well as the smoothness of the surface is important. If it is falls on the rough reflecting surface, also the the light will in different angles it will reflect, so you don't get the proper uniform reflection, right? So basically the nature also matter and the smoothness also matter. So the right answer for this question is option C. It depends on the nature and smoothness of the surface. The magnification is equal to the ratio of size of the image to the size of the object. Okay, the 21st question. So m equals, magnification is represented by m, hi divided by h naught, right? So this is the right answer. Okay, so I can say that true. The formula is m equals hi divided by h naught. Hi is the height of the image divided by height of the object. 22nd one, distance measured above the principal axis are taken as. So let me say that this is the principal axis, this is a normal. So now what will happen? You want to measure anything above the principal axis along the positive y-axis. Okay, it should be taken as positive. Let me say that h naught, height of the object AB, which is on the principal axis. So we should take as a positive. Anything is below the principal axis, perpendicular to the principal axis. Let me say that image. So we should take it as negative. Okay. So we have to follow the rules of Cartesian sign convention rule. This is the y-axis. This is the y dash axis, x-axis and negative x-axis. Let me take it as x dash. Anything you are measuring along the y-axis, I mean positive y-axis, we should take it as a positive. Okay, so the right answer is true. Okay, above the principal axis, anything which is standing, okay, either here it is standing, wherever, we have to take it as a positive. Anything is inverted like this, head is inverted here, upright, down. So what will happen? We have to take it as negative in this direction. In this direction, we have to take it as a positive. I mean, in the upward direction. Light travel faster in vacuum. Vacuum means empty space where no air, no temperature, no atmosphere, no disturbances. So the light will travel faster in this 3 into 10 to the power 8 meter per seconds, right? And via wood, the light cannot pass because it's opaque. So it will not allow a 1% of light to pass through it. So it is impossible. So, and glass depends on what kind of glass we are using it. So, so that is basically depends on the what kind of material we have used. So, and water also. So light will travel faster, but it is basically like what kind of water it is. It's a mud water or salt water, or it is a fresh water. Basically, they depends on that. The speed also varies. But right answer for this question is vacuum. 24th one, the divergent lens will produce. What is the meaning of divergent lens? So we have discussed already. Okay. Concave lens is considered as a divergent divergent image, diverging lens. So it will always produce a virtual image. Okay, so remember, convex, I mean divergent lens or concave lens will produce always virtual images. Okay, the right answer for this question is option B. 25th one, a ray of light is incident on the plane mirror normally. The angle of incidence and angle of reflection are dashed respectively. So let me say that this is the plane mirror. Okay, you take it as a plane mirror. This is the normal. Whenever the light passes via normal, okay, I mean it is passing via normal, so the angle of incidence will be taken as 0, and obviously it will reflect back in the same path. It follow the same path only, so angle of reflection also equal to 0. Okay, remember, whenever the light passes via normal, the angle of incidence and angle of reflection will be equal to 0. So the right answer for this question is option C, 0 degree. 26th one, a 10 millimeter long owl pin is placed vertically in front of a concave mirror. A 5 millimeter long image of a owl pin is formed at 30 centimeter in front of the mirror. What is the focal length of this mirror? So now we already know that magnification of the mirror is minus V divided by U. That is, I can take it as H I divided by H naught. We have discussed this formula earlier, right? But now what I will do, what is V here? V, let me take it as a minus 30 centimeter. They have given here the image is formed at 30 centimeter front of the mirror, but we don't know the U, right? And what is HI? HI, I can take it as, okay, height of the image is minus 5 centimeter. And what about, because minus is here, we can see that same minus I have taken here. What about height of the object? So height of the object is, let me take it as 10, right? Now what will happen? We have to find the U, right? So it will take the cross multiplication. So U equals minus 30 into 10 whole divided by minus 5. 5 ones are, 5 twos are, right? So the answer is, here I can take it as, so 5 ones are, 5 twos are here, 5 twos are 10. So here 30 into 2, that is minus 60 centimeter. Is it clear? So U equals minus 60 centimeter. Now what will happen? We have to use the formula 1 divided by F equals 1 divided by U plus 1 divided by V. So now what will happen? 1 divided by F equals, what is U here? U, we got it 1 divided by minus 60 plus 1 divided by minus 30. What is the LCM of both? Okay, LCM of both is, let me take it as minus 60. 60 watts are 61s are minus 1. Okay, so this is plus 60, and here plus into minus minus 30 watts are 32s are, right? So now what I can write is minus 3 divided by 60. 3 ones are 3 20s are. So now what will happen? I can write it as 1 by F equals minus 1 divided by 20. But if you take the reciprocal, F equals minus 20 centimeter. So here I just by the wrong multiplication, 5 ones are, you can take it as 5 6 also. Okay, that is left to you. Okay, 6 into 10, you can take it as a 30. However, you can multiply, or else you can say that 5 ones are 5 twos are. Whatever the multiplication you can take, no problem. So, but the right answer for this question is minus 20 centimeter. Okay, we'll move to the next question. The focal length of the mirror is minus 20 centimeter. 27th one, dash is a diverging lens. The right answer for this question is concave lens. Concave lens is considered as a diverging lens. Okay, so all right, how about prism? Prism is an optical medium, okay, which is bounded by two triangular faces and three rectangular faces. Whenever the light passes through it, inside the prism the refraction will take place, and whenever the white light passes through the prism, it is going to split up into 7 constituent colors. So that is prism, right? All right, but right answer for this question is option C. 28th one, under which of the following condition a concave mirror can form an image larger than the actual object? So option A, when the object is kept at a distance equal to its radius of curvature. No, doesn't matter here. When the object is kept at a distance less than its focal length. No. Okay, when the object is placed between the focus and the center of curvature. So I have attached one image here. Whenever the object is placed between the center of curvature and focus, the image formed will be little bigger than the object. Okay, so the right answer for this question is option C. When the object is placed between the focus and the center of curvature. 29th one, the diagram showing the correct path of the ray after passing through. Option A, second and third. Option B, first and second. Option C, 1, 2, 3. Option D, 1, 3, 4. See, this is one of the most important concept we have to remember. See, first diagram says that whenever the light ray passes via optical center, it will go undeviated, either whichever the direction you take. So whenever the light ray passes via optical center, it will go undeviated. Okay. In the second diagram, what it says, whenever the light ray passing parallel to the principal axis, after refraction, after passing through the lens, it will passes via focus. So this is the first diagram is right, second diagram is right, and third diagram, whenever the incident light ray is passing via focus, then after refraction, what will happen? It will go parallel to the principal axis, ulta of this diagram, right? So, but in the fourth diagram, the incident light ray is going via focus, but after refraction, again, it is going via focus. So this is wrong. So, but the right answer for this question is first one, second one, and third one. So we have to remember these rules to understand, to draw any images related to the lens in the upcoming questions. Okay, these three rules is very, very important. Okay. 30th question, a light ray enters from a medium A to the medium B as shown in the figure. The refractive index of medium B relative to A will be, see, let me say that this is the air medium and this is the water medium. Simply I'm saying, you can take any example. So let me say that this is the angle of incidence, and what is happening? This is angle of refraction. So basically, the angle of refraction is less than angle of incidence. So obviously this is the rarer medium and this is the denser medium. So if it is a option, I mean the medium B is denser, means whose refractive index will be more than medium A. So I can say that the right answer for this question is the refractive index of the medium B will be relative to A, I mean greater than A. Okay, that's why where the speed of light will reduces, that's why it will bend towards the normal. Okay, all right. So the right answer for this question is option A. So till now I have discussed almost actually 30, but with answers I have discussed more than 40 to 45 questions. So kindly subscribe this and share with your friends. Okay, if you want to share any feedbacks also, there is a comment box. You can post me the comment, and in the main screen I have posted my number also. You can post me the any feedbacks. Okay, thank you very much. All the best.